Thank you very much. Well, BAZOOCA is a project. It's all about how to regulate the Baltic Sea fisheries and eutrophication through ecosystem-based management. So, and our aim has been to look at the zooplankton, that is trophic levels below fish, really. And starting with the situation in the summer of 2009, when we were out looking on our cruises, we can see here the main fish and also jellyfish in the Baltic. We see main predators on zooplankton, which we have here, are sprat, and herring is about half of that, the biomass, and cod is much less, of course. I marked here in parentheses how much we fish out of the stock, and actually what we fish are marked in blue here. So roughly 1/4 to 1/3 of the fish is caught every year. Note here that the jellyfish are still quite important, with biomasses sort of in between sprat and herring, showing a big potential actually for them to graze or to feed on the zooplankton. So we started out trying to determine how big are these arrows really. And here you can see then the predation by the different species. And you can see that herring and sprat are by far the most important predators on zooplankton in the Baltic. They peak in September, October, and only at the same time there are Aurelia, the jellyfish, of any importance, and they reach a couple of percent. So, as it looks now, or that in 2009, the jellyfish were not very important for the feeding on the zooplankton. But the reason why we got the money for the project was actually the potential introduction by a comb jelly named Neniopsis. And turns out that it didn't appear really, but if it had, whoa, this is the whole project idea here. If it had, we would have had a lot of Neniopsis here. We would have had a lot of feeding on the zooplankton here. We would have less food for the sprat, herring, and also cod. And so this was a big threat. So, as I say, we didn't find that. And why did we not find that? Well, we have shown in experiments that the reproduction of Neniopsis in the Baltic could not occur at the salinities in the central Baltic. Here you see number of eggs produced per animal, and you see at 6 parts per thousand, basically no reproduction occurs. But note here that already at 10 parts per thousand, we have a substantial reproduction. So we're doing experiments now to see if we have an evolving tolerance to this. Could be that the Neniopsis that we now found permanently in the keel bight and in the Belt Sea could actually adapt to the Baltic salinities, and then we have a problem, because these animals grow very fast there. But what we did then with the present jellyfish abundance or species, we estimated what could happen to that in the future. Well, 2 scenarios. We looked at, it has been suggested to increase the fishery on sprat, so you would reduce the number of sprat here, with the idea being that the zooplankton would increase, and that would be beneficial for cod larvae and the sort of regrowth of the cod population. However, as you see here, another option, what could happen is that we could get a lot more jellyfish, and that would certainly happen, and that's not a wanted effect of this kind of management. You see here pictures of Aurelia, the common jellyfish in the Baltic, but they have a rather slow growth. They have generation times of a year or so, so this would be a gradual increase in jellyfish. The other scenario, or the other thing that will happen in the Baltic, is that we have increased eutrophication, and that also is bad for the zooplanktivorous fish, because what happens is when you have less water clarity, as Marcus showed, the Secchi depth would decrease. We will have a lot less, the visual feeders cannot find prey at the normal distances, but much closer to them. And that would mean make them less efficient as predators. So feeding on zooplankton will be less by sprat, and increasing in jellyfish are to be expected. So those are the sort of balancing thing that we investigated in the project, and we have concluded then basically from what we've done so far is that we found no Miniopsis invasion, and we have shown that salinity was too low for reproduction. We also found that there was no predation on cod eggs, that was mentioned here. That was a fear that they would actually feed on the cod eggs, but they did not. And even if they were present in the cod reproductive areas. And we have seen that increased fishery on sprat and eutrophication could lead to more jellyfishes. And the whole idea then with this project is that we want to emphasize the importance of when you do the fish management, you must consider the route to jellyfish here. And we also would like to emphasize on the side of this that we think that the management of fish will be a very important tool even to combat eutrophication. And that is because the fish, that's where you have the big, the top predators. And all these eutrophication problem, they happen if you do not have top predators around. If you have them around, most of the system will just grow if you put in more nutrients in the water, and you can harvest more fish at the top. But what top predators also do is they sort of dampen the inputs. And if you remove them, that's when you get the problems. So I don't know if this is very controversial. It's probably not. But a good way to combat eutrophication would be to restore the top predators into the Baltic. Thank you.